Hi class, today we're going to work with array structures, which is chapter 7 in our textbook. There is an associated Rebel course, which should give you some practice on some of these things that we'll be talking about. When we're working with arrays, we'll get right into a picture. These are structures that are actually variables themselves, but they hold repeating data, so they allow us to more efficiently save information in our program. We have to allocate an array before we can use it, just like any other variable pretty much in C#. All entries in the array have to be the same data type. And once allocated, the size of the array can be updated. So let's think about some variables. We could have different data types for different variables, holding different pieces of information and different kinds of information. And we've come far enough to know that we want to select the right data type, bool, decimal, string, double, int, depending on our data. So the characteristics of our data are going to determine which data type we should use. So what if we want to keep track of more than one name? We want to keep track of several people's names. Well, we can build an array. And an array is a repeating structure somewhat like this, where I can have multiple names in a list. So first of all, when we're working with these list items, we need somewhere to keep track of which thing is which, and we use an index to do that. And an index is simply just an integer, and we use it as a pointer, and it points to a certain array entry. We might also see it called a subscript. Our index values always begin with 0, and for example, the index value for our entry Tammy is 2. So we could say name and then square brackets, the number 2, and that would indicate that we were looking at Tammy's entry. Now we could also change Tammy's entry by saying name square brackets 2 equals something new, a new name, and that would update that value in the array. So an array is just a collection. Now here's another one. We have an integer that's our age. We have it set equal to 5. And then we decide that instead we would be better off with an array of integers. So the code at the top in the black line allocates an array of integers. So we can see the square bracket. We'll talk about that in a second. Our array is named age, and it's given some initial entries. So there's all of our initial entries. Now the entries must fit in a contiguous spot in memory. That means if I have 457 entries in my array, I need to be able to find room in memory of the computer that's running this program for those 457 entries back to back. Nothing else in between. They must be contiguous. Now, here at the top is our index that's shown for this integer array named age. And below that, we have the value that ends up in this array after we process this statement that allocates the array named age and gives it these initial values. So we can see our initial values. 16 was put in the first slot with an index value of 0, then 45 was put in second, etc. Now, here's the C# code that we would use to create this. First of all, we have the int age array being allocated and initialized. And then I have some right line statements just for you to see how we could access a specific entry in that array. Now, our array, if you remember, is named age. So we specify the name of the array followed by the index value within square brackets. So for example, age subscript 4 would print out the value 0, 1, 2, 3, 4. So our last entry in our array. Here's our output. We would expect that last entry and then subscript 0 would print out our first entry, and then we set up an index value of 5. Well, that index value is outside our array. Our array only goes to 4. So that statement would cause an exception in our program, an index out of range exception. So that's a common thing that can happen when we're working with arrays. Now let's review our syntax. First of all, when we're working with an integer, the first thing that we specify is our data type, unless of course we have an access modifier like private or public. But we have our data type followed by a pair of square brackets. Next becomes the name of our array or our identifier. And then in this case, when we're setting up initial values, comes our initial value list after the equal sign. Our initial values list is contained within curly braces. Each of the entries are separated by commas, and the number of entries here is going to determine the size of this array. So with C#, once this statement was processed, we would not be able to change the size of this array. Now, once we've got that array created, how do we access entries in that array? Well, here we're going to do that. We're declaring a variable that's going to be an integer, and we're going to call it 1age, and it's going to hold one array entry. Now, to set that variable equal to a value from our array, we would specify our array name, and then followed by the index pointer value of the entry that we want to use, and our pointer value would be within our square braces. When we have done processing this statement, our 1age variable should hold the value 24, which is 0, 1, 2, 3 entries within our age table. Now, if we want to change a value within an array, we'll specify the array name first, and then the index pointer. And again, it's going to be within square brackets. We'll always be using square brackets when we're working with arrays. Then after the equal sign, we'll have a new value that we want assigned to that array position. And then our third entry in that array would hold the value 28 after we were done. So the 29 would become 28. Now, when we want to walk the array or look at all of the entries in the array, we can hear that called several things: walk the array, traverse the array, loop through the array. They're all referring to the same thing, which is looking at each entry in the array. In our age array, remember we have these index values and these values within our array. Now for this code, we've created our array, and then we've set up a for loop. And in our for loop, we start with a variable named I that's an integer, and we initialize that variable to the value of 0. We're going to run this loop while I is less than the length of our array age array, and length is a property that's available to us through the C# array class, which we'll talk a little bit about more later. As we execute our loop, we're going to update the value of I for each iteration. Each time we execute our loop, we're going to write a line that's going to output the value of that age array. Excuse that S, there's a typo there. So that would output each entry in our array, so that we should see an output like, oops, I'm getting ahead, look at this fancy animation. So the first execution of our for loop, we would set I equal to 0, and then we would write out the number 16 because that's at index position 0 in our array. Then we would update the value of I to 1 and write out the number 45 because that's what's at that position. Then we would update I to 2 and write out that value 29, 3, and we would write out the value 24. Finally, our last entry, position 4, we would write out the value 14. We would end up with this output where we just printed out each of the different values that we found in our array. Now, again, we have our array and we'd like to look at each entry, we're going to use the for each statement. So the for each statement, if you look at this code, gives us an opportunity to use a different construct to walk the array. So we have our same age array here, and we have a for each loop. And we'll talk about its syntax here in a minute. But let's think about our array structure here. Within our for loop syntax, we're calling each entry in the array entry. So that's the variable name we've chose. And we've said that we want to look at each entry in the age array. And for each of those entries, we're going to write out that information to the console. So here's how this for each loop will work. We'll start out and we'll get to see that number 16, that very first entry. Notice that our index is not available to us with the for each loop. We just see the actual entry. The next time our for each loop iterates, we'll get that value 45. Then we'll get the value 29. Next iteration, the value 24. And finally, the last value of 14. Notice that as I'm processing an entry in my array, the previous entries and the preceding entries and the following entries, none of them are available except for this particular entry right now. That's how my for each loop works. Now we end up in the end with the same output as we had earlier, just a list of all of the array entries. The for each loop has specific syntax. For each is the actual keyword that we've got to use. And then we have for each criteria. And that criteria is enclosed within parentheses. And in our criteria, the word in is required, and it specifies how we're going to process this data. Within this criteria, first we have the data type of our array entries. Our array is an integer data type. We could have string or double or anything there, depending on how this array that we want to process is set up. So data type, then name of the variable, and this will just be a local variable within our for each statement, the name of that local variable to hold each of those array entries as they are processed. Then lastly, after our in keyword, we want the identifier or name of the array to be processed by the for each statement. So the for each statement is a super effective but read-only way to process all of the entries in an array. Now, when you're working with array processing, you want to make sure you see the REPL courses, or course, for practice assignments, because it'll give you a lot of experience. There's some good exercises in our textbook, and that should help also. The course for REPL is C#, he went that array, and there are several sample programs. Now, another concept that we want to think of when we're working with arrays is parallel arrays. So what if I wanted to keep track of several different people and their ages? Well, I can't do that with one construct in C#, because C# says that arrays have to be one data type. So I couldn't mix up integers and strings. So what I can do instead is set up two different arrays, and in my program myself, I'll treat these as parallel arrays. So that means for every entry in my age array, I'll have an associated entry in my name array. So Joe here is 16. They both have index value 0. Then Bill is 45. Again, they share the same index value, so I know they're related to each other. And in the same way, I could just load the data into my array that's dependent upon whatever I need to keep this data in parallel. Now I would have to programmatically make sure that that happened. If somebody wanted to change new name's name, I'd want to make sure that I had the right entry, of course, and that would be logic that I would take care of in my program to handle this parallel array. Now, when we're working with arrays, sometimes we need to pass data to a method in our array. So this is a great time to revisit the method syntax, or terms, I guess, of passing by value and passing by reference. This first example here shows an example of passing by value. In my main method, I have two variables, my int that has a value of 12 and a double that has a value of 2.5. I want to call this method update int, and this method requires an integer as and a double as input parameters. So when I call update int, I'll specify my variables that I want used as parameters. So I want my int to become the num variable within that update int method, and I want a double to become the multi variable within that update int method. So of course within update int, I don't have to have any declaration statements for these variables because they are declared here in the method header. Now, because they are being passed as parameters, the value of those parameter arguments that are passed to me, that absolute value, is placed into or initialized into my variables here. So my num variable is a value of 12, and my multivariable is a value of 2.5. Now, if I look at my code here, all I'm doing in this update int method is returning a value, and that value is my num variable times my multi variable. So that would give me a value of 30, which is going to be returned back to my main method and will become the value within my new int variable. Okay, so what's important about this? Whenever I call update int, copies of the variables are created. So anything that my method does to these variables, which it doesn't do, but if it updated them, it wouldn't affect the main method because these variables, these instances would be destroyed when this update int method was done running. They're local just to that method. When we return back to our main method, our execution would continue on with these original main method instances of the variables. So we'd have duplicates in memory. So that's passing by value. The value of a variable is passed into the method, and the method has its own new variables to hold that value. Now, passing by reference is a little different. And passing by reference is what happens if we pass an array. So it just happens automatically. We could also use the ref keyword in C#, but since we're working with arrays, we'll just show you how it works with them. For this example, we have an integer array that has these values, and we've called it int array. And then we are going to, in our main, call a method update int, and this method expects to have an array of integers passed to it, and it calls that array AR. So when this method is instantiated or control is passed to this method, our int array will actually not be copied to this AR. What will happen is AR will be set to an address, a pointer, that points to the actual int array. So within my method, when I declare a sum and do a for each and add to it and return to it, I'm actually working with the same memory location as the main. So I don't get a copy of the data in array. So if I were to update this array in my method, those updates would be available to my main method, or they would affect my main method as the case may be. So whenever we're working with arrays, the system automatically passes by reference. That's because an array could be huge. So I could have an array with 2 million entries taking up 2 meg of memory, right? And if I had this array with 2 million entries, I sure wouldn't want to make a copy of it just to pass it down to a method. So the system tries to save resources for all of us and instead just creates a pointer to that array position in memory. So let's look at our code here. We declare our integer array and allocate some values. Then we declare a new integer and we load it up with the value returned from our update int method. Our update int method expected an integer array to be passed to it, and we passed our int array. It went through a for each loop and added each of the entries in our array to a sum and returned that sum. So that value then was returned to the main method as new int. So super cool, it just automatically passes by ref. We can do it manually if we specify that ref keyword. Now when we're working with arrays, we're automatically creating an instance that's derived from the system array class. And we can think of derived as kind of being a child of that system class. So that means that we have access to all the methods and properties of that system array class. So you can look at the MSDN documentation online or your textbook for a list of often used array class methods. And here's a few super handy ones. We can do array, in the word array meaning the system array class. We can call the sort method and pass in our name array, and that would sort that array in ascending order. We could also do the array.reverse and pass in the name of our array, and that method would reverse the order of those entries. Another method that's available to us, we can call it by naming our array as the array, and then using a dot to call the method. We can use the getValue method, and the getValue will return whatever value it finds in index position 3. So just a different syntax for us to access the values from the array. So in summary, arrays allow us to manipulate repeating data elements efficiently. Arrays can be efficiently handled using for loops. The for each statement allows us to easily process all entries in an array, and you need to create practice programs to work with different data types, values, and conditions so that you feel like an expert in working with arrays. Thank you.